Welcome to this AI-generated deep dive created using Notebook LM. Today, we're exploring an article written by my colleague, Bill Constantine, here at Xyonix. The article examines AI-powered data imputation with autoencoders, a state-of-the-art technique that outperforms traditional methods like random forests. This discussion is grounded in real-world data, and we've included all the Python code in a Jupyter notebook so you can easily replicate or expand upon our work.
All right, so today we're going to dive into something that can really make or break any data analysis, and that is dealing with missing values in data sets.
Yeah, those pesky gaps.
Exactly.
That can really throw a wrench in things.
Yeah, you can start questioning your whole analysis.
Oh, absolutely.
When you've got holes in your data.
Yeah.
So we're going to explore how AI can be our new best friend in this whole process.
Yeah. AI-powered data imputation.
That's the term.
Using a really cool technique called autoencoders.
Okay, cool. So we're going to get into that.
Yeah.
The source for our deep dive today is an article from an AI consulting firm, and they've been doing some really interesting things with data imputation.
Yeah, they have some pretty impressive results, actually.
Yeah, so let's start with the problem.
Okay.
I mean, what happens when you're trying to analyze something like housing prices,
Right.
but you're missing income data for like half the neighborhoods?
Oh, it's a nightmare.
It's like trying to bake a cake with like half the ingredients missing.
Exactly. You can't get a complete picture of what's going on.
Right, and that's where imputation comes in.
Yeah. Instead of just throwing out that incomplete data,
You're right.
we can actually make some estimates to fill in the gaps.
Okay, so, I'm thinking, well, couldn't we just use the average income
Oh,
for those missing data points?
that's what a lot of people think.
Yeah.
But it's not really the best approach.
So what's wrong with just using the average?
Well, it's like assuming that everybody in that neighborhood earns the same amount,
Right.
which we know is not true.
Yeah, it's way too simplistic.
Way too simplistic, and it can lead to some pretty inaccurate results.
Okay, so the average is out.
Out.
So what's the smarter way to do this?
It's these autoencoders.
Autoencoders, okay, I'll admit it sounds a little intimidating.
It does. It's actually a very elegant solution.
Okay, so break it down for us.
All right, so think of it like taking a high-resolution picture and compressing it into a tiny file,
Okay.
like a ZIP file or something like that.
Yeah, get that.
So essentially, that's what an autoencoder does.
Okay.
It learns to capture the essence of the data, even in a compressed form.
Interesting. So how does this compressed essence help us fill in the missing data?
Right. So when we have missing data, we can actually feed the partial information that we do have
Okay.
into this trained autoencoder.
Mm-hmm.
And it uses what it's learned about the relationships between the data points to actually reconstruct those missing values.
Wow, so it's not just randomly throwing in numbers.
No. It's using its knowledge of the data structure to actually make a very informed guess.
It's like it's learned something about the data.
Exactly.
That's pretty cool.
Yeah, and what's really neat is they actually tested this on a real-world housing data set.
Oh, wow.
They introduced some missing values, and then they compared how well the autoencoder performed against a more traditional imputation method called random forest.
Okay, and I'm guessing the results were pretty impressive.
They were very impressive. The autoencoder was consistently more accurate in filling in those missing values.
Wow, how much more accurate are we talking?
Sometimes 3 to 6 times more accurate.
That's a huge difference.
It's a game changer.
Wow. Okay, so what does that actually mean for someone who's, analyzing data?
It means you're getting a much clearer and more accurate picture of what's really going on in your data set.
I see.
So, if you're missing key information, you might miss important trends or correlations.
Right.
But by using an autoencoder, you're essentially sharpening your analytical lens.
So it's not just about filling in the blanks.
Yeah.
It's about getting a deeper understanding of the data.
A much deeper understanding.
Yeah, okay, but how does this magic actually work?
Well, that's the million-dollar question.
We'll have to uncover that mystery.
Okay, next part.
The next part, stay tuned. Okay, so we've established that autoencoders can really work wonders for filling in those missing data gaps.
Mm-hmm.
But I gotta admit, I'm still a little fuzzy on how this whole essence capturing thing actually works.
Yeah, that's a great question.
Like, how does it actually happen?
It's all about training the autoencoder.
Oh, okay.
So think of it like teaching a student how to recognize patterns.
Right.
So we feed the autoencoder a ton of data, and it starts to learn the relationships between all these different data points.
So in the case of our housing data, it would be learning how things like, average income
Right.
property size, location.
Exactly. All of those factors.
How they all relate to each other.
Yeah, it starts to build a sort of internal blueprint of what a typical data point in that data set actually looks like.
Interesting.
And that blueprint is what allows it to make such accurate predictions when it encounters missing values.
So it's not just, blindly filling in some random number.
No, not at all.
It's using its knowledge of how the data is structured.
Exactly. It's making an educated guess based on what it's learned.
Right, because I remember you mentioned earlier, like traditional methods like random forest.
They also try to predict missing values based on patterns in the data.
Right, they do.
But you said the autoencoder outperforms it, so...
Yeah, that does, yeah.
How come?
Well, random forest is kind of like taking a bunch of different polls
Okay.
and averaging the results.
Okay.
It's a decent technique.
Yeah.
But it can be a little bit limited when you have these really complex relationships in your data.
And autoencoders can handle that complexity better.
Much better.
Okay, how so?
Well, because the autoencoder goes through this compression and reconstruction process.
Okay.
It's forced to learn a much deeper representation of the data.
Interesting.
It's like discovering those hidden connections that other methods might miss.
And that's what allows it to make such accurate predictions when data's missing.
Exactly.
It's like the autoencoder saying, like,
yeah,
I know this neighborhood like the back of my hand.
Right.
Based on everything I've learned, this missing income value should be around this much.
Exactly. That's a great way to put it.
That's amazing. And that's what makes this research so compelling.
Yeah.
They weren't just, theorizing about this.
Right.
They actually tested it on real-world data.
And they got those, 3 to 6 times.
3 to 6 times accuracy improvement.
Yeah, it's huge.
It's a game changer.
I'm starting to see why this is causing such a buzz.
Yeah.
But you mentioned earlier that autoencoders could do more than just, fill in missing values.
Oh, yeah, absolutely.
What else can they do?
They can also be used for things like anomaly detection.
Okay, now anomaly detection.
Yeah.
I'm curious about that.
So, for example, let's say you're a bank
Okay.
trying to prevent fraudulent transactions.
Yeah, that's a big problem.
Huge problem, right?
How would an autoencoder help with that?
So you could train an autoencoder on a massive data set of normal transactions.
Okay.
So it'll learn all the patterns,
The typical amount.
exactly the usual times a day, the types of vendors,
Okay.
all that stuff. And then if a transaction comes along that deviates significantly from those learned patterns, the autoencoder could flag it as potentially fraudulent.
So it's like it's constantly comparing this new data
to its internal blueprint.
to its blueprint and saying, whoa, this looks fishy.
Exactly. Like, this doesn't fit.
Yeah.
Something's off here.
Okay.
And that kind of anomaly detection can be applied to all sorts of fields,
Wow. Like what?
from manufacturing to healthcare.
Really?
Yeah, anywhere where you need to identify unusual patterns.
It's pretty mind-blowing stuff.
It is pretty amazing.
But, we've been talking a lot about the how of autoencoders. I'm also curious about the why.
The why.
Like, why should someone who isn't, a data scientist care about this technology?
That's a great question.
What's the big picture impact here?
That's what we need to explore.
Okay, so we've covered like the how autoencoders actually work.
Mm-hmm.
They can rebuild this missing data with crazy accuracy. And we touched on like the what they mean spot anomalies, potential fraud, all that stuff. Exactly. But like what's this so what?
With so what, yeah.
Why should someone who isn't, like knee deep in data sets every day care about this technology?
Well, that's the key question, isn't it?
Yeah.
Because really we're all living in a world that's increasingly shaped by data.
That's true.
From the personalized ads that we see to medical diagnoses, like data analysis is happening everywhere.
Behind the scenes.
Yeah. It's impacting our lives in huge ways.
So you're saying that by like improving the accuracy of our data analysis, we're actually improving like the quality of decisions that are being made.
Better decisions.
Okay, let's go back to that housing market example.
Okay.
Imagine you're a city planner trying to, develop affordable housing policies.
Right.
But your data on neighborhood incomes is like riddled with gaps or inaccuracies.
You can have a problem.
You're working with like a distorted picture of reality.
Totally.
Your policies might not even work.
They might miss the mark completely.
Yeah. Failing to address like the real needs.
The real needs of the community.
Yeah.
Yeah.
But if you use an autoencoder to fill those gaps accurately,
Right.
you're working with a much clearer understanding.
Clear of the situation.
Oh, exactly. You can identify the neighborhoods
Right.
most in need.
Target those resources.
Exactly.
Make more informed decisions.
Yeah, and make a real difference.
So it's not just about like numbers and algorithms.
It's not.
It's about like,
It's about using those tools to actually make a positive impact.
Yeah, to like make a real difference in people's lives.
Exactly.
That's cool.
And it's not just urban planning.
Whatever.
You know, this technology has implications for healthcare finance, environmental science, like any field.
Wow.
Where data plays a big role. It's almost like these autoencoders are giving us a superpower.
I like that.
The ability to see patterns and connections.
That we couldn't see before.
Yeah, that were previously hidden.
Yeah.
That's a good way to put it.
It's like unlocking the true potential of the data.
Yeah.
So we can make better decisions, solve complex problems, and hopefully shape a better future.
I'm thinking about like all the data sets I work with.
Yeah.
It's amazing to think about like the insights that might be lurking.
Just waiting to be discovered.
Yeah, just beneath the surface.
And that's what makes this field so exciting.
Yeah.
We're just scratching the surface of what's possible with AI.
Well, thanks to this deep dive, we're one step closer to understanding those possibilities.
We've learned about autoencoders.
A powerful tool.
Yeah, a really powerful tool.
That can totally transform how we approach missing data.
And how we extract those meaningful insights.
Exactly. So to our listeners, think about the data you encounter.
In your own lives.
In your work, your hobbies, your community.
Remember that there's a wealth of information.
Yeah.
Just waiting to be uncovered.
Hidden beneath the surface.
And with tools like autoencoders,
we have the power.
We do.
To unlock those insights.
And make a real difference.
Thanks for taking us on this incredible journey.
My pleasure.
Until next time, keep exploring.
Thank you for joining us for this AI-generated exploration of autoencoders and data imputation. Don't forget, all the Python code is included in the accompanying Jupyter notebook, making it easy to follow along or adapt for your own needs. To learn more about how Xyonix can help solve your AI challenges, visit us at www.xyonix.com.